Okay, so welcome to our meeting. Like I said, this is just to give you an additional place to ask questions about the ENSA class and get information about it. If you do have any particular item you want me to go over, obviously I'd like for you to email me what those items are, and also just unmute and tell me what you'd like to see, because I can go over any of these items in the curriculum that you're in right now, or go over items you've already covered. I will tell you, even though there's 14 modules in this particular course, I do feel like this course is probably the least in depth of the two or the three in the sequence. For instance, like the module 3, network security concepts, is just straight out of pretty much straight out of Security Plus, with a little bit of information about how to do some things on the routers and switches, but very little that actually is above and beyond. And then the ACLs are now very simple, because we only do standard and extended ACLs versus doing standard extended ACLs for IPv4, IPv6. We're only doing IPv4 now in CCNA. We're not doing IPv6, which is always a little bit interesting. So what would you like for me to cover today that I can help you with in this course? Remember, you're muted, bottom left-hand corner of, well, depending on how you're set up now, if it's sharing, it may be along the top left for your mute.
I'm doing pretty good, Kelly.
Okay. Anybody have a particular item you want me to look at? Dr. Harrison?
Sorry, running late. I was in another meeting.
That's okay. I told everybody I've got a hard stop today at 4 too. I have another meeting. Is there any particular item you would like for me to go over? Any particular setup or the item in the curriculum that's giving you trouble or you're having questions about? I can pretty much go over anything in here for the most part.
So far, everything's been pretty good. Any errors that I had when I was doing it was me fat fingering things.
Which does happen, very common. I was telling a little bit earlier, I do think even though there's 14 modules in this particular course, it's a little lighter on content than some of the others. I will say one of the things to keep in mind again is, some of this is, all I'd ask you to do is to know what it is and how it works, not necessarily how to configure it. But I will tell you, one of the things you will need to know how to configure Ospf, single area Ospf. You will need to know how to do and configure NAT, actual NAT. So that's a huge topic there. And if I was looking at the major areas for this particular course, and I'm teaching it to my students, Ospf is one, and that is a huge one. Access control list, huge, because ACLs are used for everything in Cisco. They're used for everything from securing, traffic using a packet-based filter. ACLs are used to control access to your VTY lines, being able to see who can SSH into a device using an access list assigned to a VTY line or to the VTY lines. It's used for routing control and route maps. It's used just everywhere you look inside of Cisco, you will find access control lists being used as part of the iOS. So you'll find them everywhere. So that would be one of the major topics. So again, let's pull up Notepad and I'll stick major topics in here. And I'm not trying to assert Kirby or anything. I just wanted to be here in case you needed me. Ospf, ACLs, huge. NAT is huge because it's such a major topic and so important. Everybody's running NAT at home, whether they believe it or not. And then I will tell you, one of the things that you need to be careful with is this last module here, this network automation. You need to really spend a little bit of time in it because it is a new thing, and because it is new, it is on the exam, and it's part of the exam itself. It's like 10 or 15% in our mapping. So I do want you to spend some time on that and make sure you do pay attention to it. And really the big thing is a lot of the data formats, They're going to ask you to be able to look at a snippet of code and tell whether or not it's YAML, XML, or JSON. So it's really important that you know the difference between each one of those and what they look like. So again, here JSON uses what I call the squiggly brackets and the key, and it's a key and then a value. YAML uses just key value with no none of the squiggly setup of JSON. And XML, the way to remember XML is remembering that it is just like pretty much like HTML, using the slash, to start, no slash, and then slash. So that begins and ends the message. So that helps you with that XML.
Yeah, I think it's also the only one that uses the caret symbol.
Sure is. It is the only one that uses the caret symbol. So that's another easy way to remember XML. YAML, by the way, does stand for yet another markup language. So if you ever are asked about that, this is JSON as it relates to kind of looking at interfaces, and we'll learn that down the road you can actually configure routers with Python scripts using these types of JSON output, so that you can actually have it set up to where it will put in a description for you and also automatically put the IP address in it, or you can pull information off of a router using REST APIs and other ways to connect to the router and pull that information off. So I just want to mention that because that is a key item, I would say, inside of here. Let's just do a real quick overview of OSPF, just to give you a little more review on it. One of the things I'll tell you about OSPF is OSPF is a link state routing protocol, okay, which that is different than our other routing protocols we have discussed, which are distance vector routing protocol. So link state routing protocols, they do use more CPU and more memory than distance vector. And the reason they do it, it's pretty easy. The second you start looking at the way they are, OSPF is set up. Because when you look at OSPF, one of the very first things they mention is that OSPF consists of multiple different tables. In other words, with our typical distance vector routing protocols, you basically have a DV, you have a routing table, and that's it. You don't have anything else. Now, I do know that if you ever study EIGRP is a modified distance vector routing protocol, but link state, however, link state usually has multiple tables. One of them is a neighbor table. Then you're going to have a topology table. And then you'll have the routing table. So just alone by looking at the number of tables it keeps up with, you can see that link state routing protocols use more memory and more CPU because they're having to maintain these tables. There's also got to be in place the mechanisms to create these tables. And that's really what OSPF, this area is talking about. It talks about the 5 different packet types that are used. Hello packets, which are used to establish neighbor relationships. Database description packets, which are used to share database information between different routers. Link state request packets is when a router wants more information about a particular network. It can actually send a request to say, tell me more about network 10.0.0.0/30. And then it would get a link state update packet in response to that. And then it would send what is called a link state acknowledgement in response to the link state update. Say, yes, I did get that information. And these are the databases. They call them an adjacency database, which is the neighbor table. The link state database, which is the topology table that keeps up. And that's another key difference between distance vector and link state. In distance vector, all the routers really only see the network from their vantage point. They don't see the entire network. Under link state, they see the entire network's topology. So they have this link state database, which is a topology table, which will show you the entire network and all the different links, especially if you do, there are ways to say show all links, and it will show you all the links in the entire network. And then finally, there is a forwarding database, which is the routing table. And that's where the best routes, which is in OSPF, the one with the lowest cost, gets placed into the routing table. And then, of course, OSPF uses what is called the shortest path first routing table, a routing algorithm, which forces it to build the shortest path based upon the cost of the links, and the cost of the links is based upon the speed of the link. So faster is typically a better link. Questions about that? Questions about, and I hope that helps you see why OSPF uses more memory and more CPU, because of those tables and the need to create those tables. It's kind of timely for me because actually I'm studying for my CCNP Encore, my renewal. So a lot of this I'm looking back through myself in OSPF just to make sure I understand. One of the first questions I was asking, a review I was doing, was how many basic packet types are there in OSPF, and it is 5. So the hello, DBDs, database descriptions, link state requests, link state updates, and link state acknowledgements are the base 5 for OSPF. Now, OSPF also has the ability to be hierarchical, and we haven't seen this in any other routing protocol we've dealt with. And it's basically for this course and for CCNA, you only need to know about single area OSPF, which is always going to be area 0. In CCNP study, you will learn how to do multi-area OSPF. And with multi-area OSPF, you can create bounded areas within which topological changes will not affect other areas. So you can actually set it up to where if a link goes down in area 1, it will not automatically cause a shortest path first algorithm reconfiguration in area 0. So that's one of the neat things about multi-area OSPF, is set it up correctly and you can create, let's imagine you've got 3 different networks in 3 different cities. And Chicago could be one of the areas of your OSPF network. New York could be another area, and then Charlotte could be another area. So you've got 3 different areas that are all self-contained.
Question.
Go ahead, see.
Kelly, how would spanning tree affect that OSPF in a multi-area, or does it?
It does not, because remember, this is layer 3. Spanning tree is layer 2.
Understood.
So what would happen is, because anywhere there's a router, nothing spanning tree goes past a router.
Okay, so
that's really off each one of these routers, everywhere there was a connection, spanning tree would be running as an instance on that network.
Okay, so it's in the background of that router.
Correct. Because it's all, spanning tree is all layer 2. OSPF is only dealing with layer 3.
Thank you.
Mm-hmm. Again, multi-area lets you have smaller routing tables. So instead of having only one big routing table, you would have a smaller routing table for each area. Reduce link state overhead because you don't have to hold all the information in your topology table. You're only holding the information for your area. That's it. And then summaries for other areas. And another good example here, again, reduce frequency of the SPF calculation. So if a link goes down here, it's not going to force an SPF recalculation across the entire section of all the areas if you've set it up correctly. The area border router will stop that. Now, there are 2 versions of OSPF, version 2 and 3. OSPF 2 only supports IPv4. OSPF version 3 supports both IPv4 and IPv6. It is, just remember, if you're running both protocols, that now means you're going to have 2 neighbor tables, 2 topology tables, and 2 routing tables, one for IPv4 and one for IPv6. So it does cost you more memory and CPU when you're running multi-protocol, but you must use OSPF version 3 in order to support IPv6. So here's our packet types. Again, the hello database description. Now, one of the things I will tell you is as you get into this link state request and updates, link state updates have, well, they're showing 5, they're showing 8 subtypes for link state updates. There's actually another couple above this. You don't need to know this level of detail for the CCNA. Just know that as you move into CCNP, you will need to know the different link state updates types, the router types, network types, summaries, and what these do in each one. But basically, the LSUs are broken into subtype, LSA subtypes, which are used in certain situations. What's important for you to know is that hello packets are very important because they're what are used to establish neighbor adjacencies. And there are timers on the hellos, and those timers do have to match in order for two routers to become neighbors in OSPF. So the hello and the dead interval must match on two devices in order for them to become neighbors with one another. The hellos are also used in order to determine BDR and DR election on a multi-access network. And we'll just talk a little bit about that in a second. One thing I want to talk about with OSPF operational states is the big problem you sometimes see is what's called stuck in a NIT. A NIT state, if you ever see a router that doesn't transition out of initialization state or a NIT, it typically means there's one-way communication for some reason. In other words, it's received a hello packet from the neighbor, but it has not, or it has not received a hello packet from its neighbor, but it sent one to its neighbor. So it's waiting in a NIT state. Typically, OSPF routers should go from down to a NIT to two-way very quickly. It should be a very quick process for them to jump down a NIT two-way. And then they get into XStart where they start sending out database description packets to each other and exchanging that information and then getting into the loading states. If you see see full, that means that the routers have exchanged all the database descriptors that they want to, and they all have a common view of the network at that point. Another beautiful thing about OSPF versus some other routing protocols is OSPF only sends updates when there's a change. So it only does what's called triggered updates. So those updates will only be sent out if it is triggered. So here again, down to a NIT, very quick, we send out a hello. We expect to get a hello back. As soon as we get a hello back, we go to the two-way state because now we understand that we've got a two-way connection between the two. And then if it's a multi-access network, we will have an election of the designated router. All right. And that's based upon the router ID. Now, the problem is the router ID is by default the highest IP address on any physical interface that's up and running. It's actually any loopback first, if there's a loopback. Well, actually, have you set the router ID? There's a router ID command, which is typically we set our router IDs to ensure who becomes the DR or BDR. You then have is the highest on a loopback. If there's nothing on a loopback, it's the highest on a physical interface. That will give you your router ID. If you have no ID at all, by the way, it will fail. Sorry, my phone's ringing for some reason. If you have no IP address at all or no router ID set, OSPF will actually fail. Let me see if I can make Packet Tracer show you that, because I'm not sure Packet Tracer will show that. But typically what happens is this. Okay, Packet Tracer, where'd you go? Oh, there it is. So if I take a router, pull a router out here, let's say 4331, pull me a switch out, put a connection between them real quickly. Let's just do gig 000 switch. All right. And let's imagine, oh, still booting. Okay. So we've connected gig 000. So if I go in here now, and even if I do, let's see, config T, config T host R1, and I do int gig 000, no shut. Okay, you should see that we now the interface is coming up. Okay, if I try to go in here now, and if I try to go router OSPF and then a process ID of 1, you'll notice it cannot start because it must have at least one up IP interface. So even though I'm in config router, it won't start because I have no up IP interface. Now, if I set a router ID, I can spell correctly. All right. Then I can do my network statements or whatever I need to do at that point. But without an up IP interface, OSPF actually will not start. So you'd want to go into your interface, gig 001 to IP add 192.168.12.1 255.255.255.0. Already done a no shut. Okay, and then I do router OSPF1, and I put in my network. And what is different about OSPF with the network statements versus some other routing protocols you may have seen in your life? Instead of using subnet mask, what do you use? You'll notice it'll tell you to use the wildcard mask. And what is a wildcard mask? Can anybody tell me what a wildcard mask is?
Isn't that one that starts with a domain and then takes the first segments or whatever?
Well, the wildcard mask, maybe, I'm not sure I understand what you're saying, Steve. A lot of times, have you heard the concept of an inverse mask? In other words, you notice.
Or the complement, maybe that you have 222, 255. You say your submask that first, like for example, 16, and the rest of them will be the wildcard mask.
Okay. So right now, let's look at this. I put by mistake, I put 169. That's fine. I'll fix that here. But the mask that I used right here was 255.255.255.0. Okay. So my subnet mask is 255.255.255.0. A wildcard mask or inverse mask puts zeros everywhere there's a 1 in the subnet mask and a 1 everywhere there's a 0. Or another simple way to do it is subtract your subnet mask from 255, 255, 255, 255. So the inverse or wildcard mask for this subnet mask would be 000.255. Because you'll notice everywhere there was a 1, I made it a 0. And everywhere there was a 0, I made it a 1. And in OSPF, you're supposed to use wildcard mask instead of, okay, so it says wildcard bits instead of subnet mask. So when you're putting in your network statements, what you would actually do is I'd put in 000.255, and then you got to give it an area, which for everything we're doing is in area 0. That's a wildcard mask. Now, let me teach you a secret. Kirby's probably already taught you this secret, but let me teach you a secret. You actually can put in, let's imagine I'm going to put in another network statement. Let's do real quick, do show IP protocols. And you will see that I'm running OSPF. I'm routing for this network in area 0, which is the 192.169.12.0.000.255 network. But watch what happens. I'm going to add another network here. I'm going to go network 10.0.0.0, and I'm going to say that it is /8. That is what I'm using as the mask for this. So it's just a normal class A. I could do 0.255.255.255. That's the inverse mask of 255.0.0.0, the subnet mask. However, one thing you're going to learn is in the real world, you actually can put in subnet mask and it will put in for you. You'll notice, look what it did. It converted it to a wildcard mask. So in the real world, even though the command tells you to put in a wildcard bit, if you put in the subnet mask, it will convert it automatically for you to a wildcard mask. That's real world. But remember, on our test world, when you're taking a test, you need to put it in as a wildcard mask, not as the subnet mask. So let's do a couple of tests here. Let's imagine I had this network. Okay. What's the subnet mask for this network? And just written out fully. /16 is what I put there, but what is the subnet mask written out in a decimal?
So the last 8 bits will be 1, right? That would be 255, followed by like
255, 255.0.0. Because remember, you've got 32 bits here. The first 2 sets.
All right, 16 bits. Yeah, you're right.
Yep, 16 bits. So that is the mask. This is the subnet mask for /16. What would be the wildcard mask for this?
Just flip it, right? 0, 0.
Exactly. Just inverse it, flip it. So it'd be 00.255.255. So anywhere there are 1s, make them 0s. Anywhere there are 0s, make them 1s. Or I'll tell you a very easy way to do this is just subtract your subnet mask from all 255s. Notice this is 00.255.255. See how that works? Okay, let's do another one. Let's do another test here. Let's do how about that? Our subnet mask.
255, 255, 255, 0
Yep, and our wildcard mask would then be
would be 0, 0, 0, 255.
exactly. Now let's make it a little bit harder. Make it a wee bit harder. What's our wildcard mask? Or excuse me, what's our subnet mask here? Well, /27. This final octet now is 224, right? Because we turned on 3 bits. 128 plus 64 plus 32 is 224. So our wildcard mask would now be, there's 2 ways you could do it. The easiest way is just subtract it from this.
31.
Yep, 31. Okay, that's the easiest way to do it. The other way to do it is this: convert 224 to binary. 1, 2, 3, 4, 5, 6, 7, 8. Okay, and then anywhere there is a 1, make it a 0. Anywhere there's a 0, make it a 1, and you will see that this is 31. So there's 2 ways to do it. The easiest way is just subtract it, because then you'll get 0.0.0.31. So that's what an inverse mask is. That's what a wildcard mask is. You need to know this, because where else do we use wildcard mask? In this same curriculum, we use it in ACLs. Remember? All wildcard masks, right here they are.
Oh, yeah, that's where you actually introduce the concept the first time.
Correct. Correct. So the first time it's introduced is up here in Ospf, because you got to use it for your configuration. And then down here in ACLs, we get into a much more in-depth description of what it is. So what I normally do when I'm teaching this is, when I'm teaching Ospf here and I'm teaching, it's talking about how to actually do configuration down here. So setting the router ID, setting your actually setting up your networks, then I actually go in here and give a brief discussion of what wildcard masks are, or inverse masks. And then we have a much more in-depth discussion of it once we get up here in module 4. Okay.
Yeah, I kind of curious. I want to ask the same question again about the access control list. So you go to provide the template 192.168 for number 10.1.
Okay.
And you get the wildcard mask that's 0.0.0.255. Now, when you receive, when the router receive a package, it will decide whether this package is allowed to pass through. Now, last meeting, I have a discussion with Dr. Kirby, right?
Right, Kirby.
What kind of operation all right, to V2. So for example, you have a package address, you go to 192.168.10.10. Now you will compare with the template that's 192.168.10.1.
Yep.
You know, what kind of comparison or like when you program, what will you write down?
Okay, let's do this. Let's think about ACLs. First off, the important thing in an ACL is this. An ACL is, remember, it checks top down sequentially. It's permit or deny statements. That's all they are. They're really pretty simple. But here's the thing about them. They are very much designed to where you have to look at the statement and compare the packet to the statement that is in place. So I'm going to make an access control list. Okay. So I'm going to say an access list 1. And remember, access lists 1 through 99 are standard. So they only filter based on the source address. But let's imagine that I've got the statement permit 10.0. Oh, here, I'll do what you said. 192.168.10.1. 0.0.0 dot, quit that, I've said yesterday, .255, okay, and then deny any, which remember, any means anything. Zero, it's quad zeros, quad 255. All right, a packet comes in. Now, here's the important thing is you must, when packets come in, they have to be compared to the access control list. So let's say a packet comes in and the source IP is 192.168.10.10. Now, first off, I would not have written my statement like this. I would have written this as 10.0 because quite honestly, if there's 255 at the end, that means ignore that entire octet.
Right. It doesn't matter you whether put 1 or any other.
You put anything here at this point, and it wouldn't matter because this says ignore the final octet. Okay. So I would have written this as that. Now, this comes in. This is the source of a packet trying to go through the router. Now, depending on how, again, we're going to say this is an inbound packet, and I've set this as an inbound access control list. So this is coming in. It's going to be compared against the very first statement. And what this statement says is, I'm going to permit any packet that begins with 192.168.10. I don't care what's in the 4th octet. Makes no difference to me. I'm going to permit it. And that packet will be allowed through. Okay.
Now, how do you compare? That's a question.
What do you mean? How do you compare?
You can compare the first 3, right? First 3 octets. And how do you compare them? That like you use the subnet mask, you use the AND operation to calculate. Say that's what.
Okay, good point. There is no equivalent with wildcard mask. The ANDing there isn't. What this says is this. What this says, this wildcard mask says anywhere there is a 0 in the wildcard mask, it must match what preceded here. So in other words, this must be 192 in the first octet. It must be 168. So it's there's no mathematical formula that we can do like ANDing. This is just comparison.
I can think of one operation that exclusive ball. If you do like 192.168.10 exclusive ball with 192.168.10, you get the 0.0.0.
Right.
Only problem is the last one, 0 and 10. When you do exclusive ball, probably you don't get it. But that already matched the wildcard mask, the 0.0.0.255.
Right.
Right.
Yeah, and I think that is confusing, but there is not a, this is not a mathematical calculation. It's a comparison. It literally says take this IP address and then compare it using this wildcard mask, and anything where there's a 0 must match. Anything where there's a 1, it does not have to match.
Okay. All right. Yeah.
So let's look at this. If the source IP was 10.10 0.0.0, or excuse me, 10. What would happen to the packet coming in?
It wouldn't accept it.
It would drop in the bit bucket. Now, here's where people get in a lot of trouble too. Let's imagine this. They go, oh, I forgot to add the 10 network. Okay, or wait a minute, that would be, let's say a /8, so 255.2. All right, now this packet comes in, what happens?
It will accept it based on the 10.
Nope, still going to get dropped, and here's why. ACLs compare top down in sequential order to each one of these access control entries. These are called access control entries. You may have heard that before, ACEs, access control, and that concept is also used in other operating systems, access control entries or entry. So what would happen? Here's what would happen, Steve. It would come in and say, okay, is this 10, does it match this statement? The answer is no. So now guess what the next statement does? Drops
It's
it.
going to kill it because it's a deny any.
Bingo. So when you write
Okay.
ACLs, you have got to be extremely careful about your logic. Typically, you have to put all your deny statements at the end.
Started to say, I was always taught that the last statement you put on any ACL is deny any.
Yep. There's actually an implicit deny any on all ACLs. So it's actually already there. So if I don't put anything, even if I didn't put this in, everything else would be denied because there is an implicit understood deny any at the end of all ACLs. So there's very few places where you're going to put the deny first. There are some. So for instance, let's imagine I wanted to deny one member of the 192.168.10 network. Well, I would have to put my deny statement first. So deny 192.168. Actually, I can use the keyword. Remember, I always use the keyword host. I can use host, or I could do deny 192.168.12.100.0.0.0.0. And that says deny that one host and then permit, everyone, permit these. Permit the other 10, excuse me, not 12, 10. Permit these other 10 networks and permit the 192.168.10 and the 10.0.0.0. So ACLs, you have to be really careful with your logic, because if you don't, you will get in trouble. One other little thing I'll teach about ACLs that I know Kirby probably mentioned, but it's one ACL per protocol, per port, per direction. Okay, what are the two directions? They're
Inbound, outbound.
Inbound and outbound, correct. Okay, so inbound, outbound. The other thing I'll teach you about ACLs is ACL creation is a two-part process. Okay, one is obviously create the ACL, but that ACL has zero effect on the router until you apply it to an interface. As inbound or outbound on an interface. If you don't do that, it's just going to be in the config and won't do anything. So a lot of people get in trouble with that. They'll create an ACL, they never apply it, and they go, well, I made the ACL, I did it, I've got it. And I'm like, but did you apply it? And they're like, oh, heck, I forgot to apply it. I do that all the time myself. I forget to apply an ACL to an interface. Or worse, you apply it to the wrong interface, because that can cause all kind of problems with blocking traffic and all types of stuff. So excellent. Any other questions? How about doing this? Like I said, I'm not trying to step on Kirby's toes. I just wanted to give you another avenue to ask questions. I have missed having class with y'all. Like I said, I enjoyed our classes greatly. So I'm just going to continue to leave this Thursday meeting on my schedule. If nobody shows up, nobody shows up. If you show up and you do want something in particular discussed, please just send me an email and say, hey, can you discuss that? Can you discuss whatever you want me to discuss? I'll discuss. I can go back and discuss things that you've already done. I can go forward to discuss things, but whatever you want me to discuss, I will do. How's that sound to everybody?
Personally, I appreciate it.
Well, I am glad to be here to help any way I can. I also want to make everybody aware, if you have any issues with your academy, just let me know. I had several of your academies start up and start getting going, which tickles me to death. That is That's my goal, is to help you get your students everything they need to be able to take these classes and get the certifications. We have companies right now looking for people. So if you had people with CCNA, we could get them some jobs. We could definitely get them interviews, if nothing else. I never promise my students a job, because I can get you an interview, but if you totally blow the interview, I can't help you. So we try to do our best. Okay, but I'm gonna stop the recording.